Let's write the next Python program. Write a program to evaluate the factorial of a given number. So for example, if we are talking of 4 factorial, this is nothing but 1 times 2 times 3 times 4, which is equal to 24. Or we could also do it 4 times 3 times 2 times 1, which is again 24. Or what we could do is we could say 4 factorial is equal to 4 times 3 factorial, 4 times 3 times 2 factorial, 4 times 3 times 2 times 1 factorial. Okay, and here by definition 0 factorial is equal to 1. Now the reason I'm mentioning all these ways is with all these, this is one method, this is another method, and this is a third method. What we'll do is write functions for each of these three methods. Okay, and most interesting would be the this method. Okay, let's see. Now def factorial method 1, and it will accept a number n. Okay, now factorial is equal to 1. Let's say for I in a range n, comma 0, comma -1. So here from n to 0, why 0? Because in a for loop, if I had mentioned it as 1, 1 will not get evaluated. Although it doesn't make any difference, but still logically it should take care of multiplication with 1 as well. So for that I need to show it as 0. And step is -1. So it will keep reducing the value of I one by one. Okay. So now what do we do here? We say factorial is equal to factorial times I, and finally return factorial. Okay, this is, so here what is going to happen? It is going to go from, say, if we are talking of 4 factorial, it will go from 4 to 1. Okay, so it will be like 4 times 3 times 2 times 1. Now let's look at the other method, factorial 2, and this will also accept a number. Here again fact is equal to 1 for I in range, and now here we are going to go from 1 to number. Remember, we have to make sure that it is 1 plus. So plus 1, and step is 1, which we don't have to mention. Okay, this is not number, it is n plus 1. And here again we say fact is equal to factorial fact plus no times I, and finally return fact. Now let's define the third method, factorial third method, and again this also takes n as a parameter. Now focus on this. Now we say return n times, and we call this function again factorial 3 of n minus 1. So if you are talking of 4 factorial, when this function is called 4 times factorial 3 of 3, so it will call this function again, and now it will be 3 times factorial of 3 minus 1, that is 2. So it will be like this. So initially it will be 4 times 3 factorial, then 4 times 3 times 2 factorial, 4 times 3 times 2, 1 factorial, right? So that's how it will go. But here there has to be some way by which it actually comes out of this function itself, because this is called a recursive calls, a function calling itself repeatedly. So to come out, it requires a condition. So if n is equal to 0, then we return 1. Why do we return 1? Because by definition 0 factorial is equal to 1. because once we reach 1, 1 times factorial 3 of 0 it will be. So the parameter that is being passed is 0. So if n equal to 0, return 1. So n multiplied by 1 will not change its value. Okay. Now let's define the main function. Say num is equal to int input enter a number. Yes. Be more precise. Enter a positive number. Positive number. Okay. Now what? Now we call these functions. We can call them via the print in the print statement itself. So print formatted output, the factorial of num, or instead of saying factorial of, I can just say num factorial using the symbol itself is equal to factorial 1 of num. Is this correct? This factorial should also be inside this. Now print, again formatted output, the num factorial is equal to, now we are going to call the second method, factorial of factorial 2 of num. Let's copy paste it, and this time we will call 3. So it is going to print 3 results, and all of them should be the same, right? So let's run this and see. First of all, let's see whether any errors. No errors. Okay, run, edit configuration, Armstrong number. Okay, where is that? This is which one? Factorial f factorial. Now let's run this. Oh, nothing happened because we have not called the main function itself. So let's call the main function. Now let's run this, and let's say 4. So 4 factorial is 24 through all these 3 methods. Let's try again. Let's say 8. Let's say uh, 20. Yes, it's all giving the same results. So please especially go through this recursive. So let me just put it as a comment, using recursion, or we can say recursive calls in a function. Recursive calls means basically factorial calling itself, factorial 3 calling itself from within. Now one thing that we have to make sure is that even though see, this is not indented, right? So if will be applicable only for this statement, and it will not be applicable to this. But if you want to explicitly show it, you should use else. So in both the cases it will work. Okay, that's it. Bye.